Welcome to Get Your FRQ On. This question is from the AB exam 2002, number 5, which is not a calculator active question. In the question stem, we're given a diagram of a conical shaped tube upside down and some various other dimensions. Using similar triangles in this question, we can determine that the radius of the cone is half the height of the water. The height of the water in the cone, and we are asked to find the volume of this cone, or the volume of water, when the height of the water is 5 centimeters, and give the correct units. All right, so using the similar triangles and understanding that the radius will be half the height based on the diagram provided, when the height is 5 centimeters, the radius is 5/2 centimeters, or 2.5 centimeters. So to calculate the volume, we're just going to use those numbers in the formula for the volume of a cone. Well, the volume of a cone is volume equals 1/3 pi r squared h. So I just substitute in 5 for h and 5/2 for r, 1/3 pi times 5/2 centimeters squared times 5 centimeters for the height. Simplifying all of that, we get a volume of 125 pi over 12 cubic centimeters, which would make sense for the volume of a conical shaped object. Volume should be in cubic units. So that would be the volume of the water in that cone. Then we're asked to find dV dt when h is 5 centimeters, also with the correct units. What's important here is, because we're going to use implicit differentiation for this, the fact that the radius is half the height will be important. We will need that in order to find an expression for dr dt. All right. First, we're going to take our volume formula and differentiate it with respect to both r and h. So dV dt is just the derivative of the volume formula, 1/3 pi r squared h. Notice that because r and h are both implicitly defined functions of t, that we will need to use the product rule in order to calculate this derivative. So the derivative would be 1/3 pi times 2rh dr dt plus r squared dh dt. Now, we were supposed to figure out, based on the question stem, that the radius is half the height. If we've done that, we should be able to conclude that dr dt is 1/2 of dh dt. So not only do we have dH dt, we can calculate dr dt by taking half of that. We're given in the question stem that dH dt is -3/10 centimeters per hour. So dH dt is -3/10 centimeters per hour, and dr dt is half of that, which is -3/20 centimeters per hour. So if I want to find dV dt when h is 5 and r is 2.5, I now have all the information I need to substitute in. 1/3 pi times 2r, r is 2.5, h is 5, dr dt is -3/20, plus r squared, again r is 2.5, times dH dt, which is -3/10. Do a whole bunch of simplification, and unfortunately this is not a calculator problem, so you do have to do this simplification yourself by hand. It isn't terrible, but it is a little bit time consuming. We're going to get pi thirds times -75 over 20 minus 75 over 40. If we simplify that, we're going to get -15 over 8 cubic centimeters per hour, which again makes sense. This is volume. The volume should be in terms of cubic units, and the rate at which the volume changes should also be in terms of cubic units, so this unit makes sense. In part C, we're asked to show that dV dt is proportional to the surface area, and then we are asked to find the constant of proportionality k. We need to use a lot of the information that we already know in order to solve this. This is typical for a free response question. You typically find different things in different parts of the question, and usually there's one part of the question where you have to use several of the bits of information that you already found. So we know that dV dt is 1/3 pi times 2rh dr dt plus r squared dH dt. We know that r is 1/2 h, and we know that dr dt is 1/2 dh dt. If we combine all of that information together into one expression, we may be able to simplify it and hopefully come up with a convincing argument that dv dt is in fact proportional to the surface area. So let's do that. All right, so dv dt is 1/3 pi times 2r times h, but h is actually twice the radius. So I'm going to put 2r in for h. dr dt is really 1/2 dh dt. So I'm going to substitute 1/2 dh dt in for dr dt. And I'm going to start simplifying. All right, so the 2 and the 1/2 will cancel with one of the 2's for the r squared. We get 2r squared times -3/10 plus r squared times -3/10, which should look suspicious. 2r squared times something plus r squared times something is 3r squared times that thing. The 3 would cancel out with the 1/3 in front, and we get pi r squared times -3/10. Well, wait a minute. Pi r squared is the formula for surface area, and we're trying to show that dv dt is proportional to the exposed surface area. Well, that's this. Well, the constant of proportionality would just be the thing we're multiplying by the surface area in order to get dv dt. Well, that's just -3/10. So dv dt is -3/10 times the area that's exposed. So that is our constant of proportionality. K is -3/10.